What is nothing? Not silence, not darkness, not empty space. We're talking about the deepest, most profound kind of nothing, the total absence of everything. But here's the twist. In modern physics, nothing might not exist at all. Welcome to the journey into the heart of reality's greatest illusion. For most of human history, nothing was just that. A void, a vacuum, a backdrop against which something could happen. Ancient Greeks debated whether true nothingness could even be real. Aristotle rejected the idea entirely, saying nature abhors a vacuum. But others, like Democritus, imagined atoms moving through a void of empty space. Fast forward to the 17th century. With the rise of Newtonian physics, space was thought of as an empty container, a passive stage where matter moved and forces acted. Newton himself believed in absolute space and time, a giant invisible box where the universe played out. But in the 20th century, Einstein shattered that idea. Space and time weren't just passive backdrops, they were dynamic. Gravity wasn't a force pulling things together, but the bending of space-time itself. The fabric of the universe could stretch, compress and ripple like a trampoline. Suddenly, space was no longer nothing. It had structure, it could bend and wave, it had energy. And then quantum mechanics arrived to complicate everything even more. In quantum field theory, the most accurate theory of reality we've ever devised, even what we call empty space is a boiling soup of activity. Virtual particles constantly pop in and out of existence, borrowing energy from the vacuum and disappearing again in trillionths of a second. This is the famous quantum vacuum, and it's anything but empty. It gets stranger. The Casimir Effect is a real, measurable force that arises when two metal plates are placed close together in a vacuum. Because certain wavelengths of virtual particles can't exist between the plates, a pressure imbalance is created, pushing them together. We can detect this effect with laboratory instruments. In other words, even when you remove everything, something still pushes back. The vacuum has structure, it has fluctuations, it has energy. In fact, physicists believe that 70% of the universe is made of dark energy, a mysterious force that seems to come from the vacuum itself and is causing the expansion of the universe to accelerate. So, is the vacuum full or is it still nothing? Let's zoom in deeper. In quantum mechanics, Heisenberg's uncertainty principle tells us that you can't know both the position and momentum of a particle with perfect accuracy. This means that even the most empty regions of space can never be truly still. There's always a jitter, a fluctuation, a restless hum. This leads to another idea, zero-point energy, the lowest possible energy a quantum system can have. Even at absolute zero, when all classical motion stops, quantum systems still possess this zero-point buzz. It's like the universe refuses to sit still. Now, enter inflation theory. The idea that the early universe underwent a rapid, exponential expansion due to a high-energy vacuum state. This process didn't just expand space, it also seeded the cosmos with tiny fluctuations that later became galaxies and stars, from quantum fuzz to cosmic structure. In other words, the universe may have emerged from nothing, but that nothing was actually a high-energy vacuum, a kind of potential energy that burst into something. Some physicists, like Lawrence Krauss, argue that this quantum nothingness is all you need to create a universe. In his book, he explains how the laws of quantum mechanics and general relativity allow universes to pop into existence without violating any known laws of physics. But here's the philosophical trap. Once you say that nothing has laws, energy and structure, is it really nothing? Let's go even further. What if we could subtract space itself? Theories like loop quantum gravity and string theory suggest that space-time might be quantized, that space and time are made up of discrete, indivisible units. If true, this means that below a certain scale, space as we know it ceases to exist. You can't zoom in forever. At the Planck length, about 10 to the minus 35th meters, space becomes grainy, like pixels in a digital photo. So what's below that? Nothing? Or something even stranger? Some theoretical models propose pre-geometry, a level beneath space-time itself, where there are no dimensions, no location, no time, only raw information. Some physicists believe the universe could be fundamentally computational, that reality is a kind of quantum code, with space and matter emerging from deeper informational rules.
Breaking news.
In this view, even nothing is something. It's a blank slate filled with possibility, a computational zero waiting to be flipped. And let's not forget cosmology's biggest question. What came the Big Bang? The standard answer is we don't know. But some ideas include cyclic models, where the universe is born, expands, contracts, and is reborn, or multiverse theories, where our universe is just one bubble in an endless foam of cosmic realities.
Breaking news.
But even if there was a before, we run into the same paradox. How does something emerge from truly nothing? Is there ever truly nothing to begin with? In theology, this is often posed as the argument for a prime mover or a creator, a being that exists outside of time and space. But physics doesn't require a divine spark. Instead, it hints that nothingness might be unstable, that when stripped of all content, what's left isn't emptiness but potential. Vacuum energy, quantum fields, mathematical structure, even randomness itself. The search for nothing has led us to the heart of everything. And maybe that's the point. Maybe nothing isn't the absence of reality, but the womb of it. So the next time you hear the word nothing, don't picture a black void. Picture a sea of possibility, a realm beyond time, a place where everything, galaxies, stars, life and you, can be born from what looks like nothing at all. And maybe, just maybe, that's where the truest secrets of the universe still hide, waiting to become something.